This will be an introduction to one-sided limits. A typical limit is viewed as approaching a height value or a function value from both the left and the right. So when we take a look at a normal limit, we might have a function, let's say, that looks like this. And we might want to know what is the limiting value, or what is the limit as we approach some x value in here. We'll call it x naught. And so even though the function has some height out, the question is what happens as to our height values as we get closer and closer to this x naught value. So what happens to the height values of the functions, or of the function? What do they approach as we get closer and closer? And we do that from both sides. And of course we have to from both sides, both the left side over here and the right side over here, we have to approach the same height value. So what I want you to notice is that as we move this direction, we move this direction. And as we move toward x naught from this direction, we go this way. So that's the idea of our limit, right? Our geometric idea of our limit. Now let's go ahead and take a look at a one-sided limit. So a one-sided limit is just half of the story that we've been working on. So watch. We may have a function that again looks like this, and we might have an x naught value. Now a one-sided limit means we have to come in at this number from just one side. The other side is not important. So if we want a left-handed limit, okay, so left-handed limit means we come in from the left side of our one-sided limit. We'll come in from the left. And the question is, what are each of these height values approaching? Well, of course, they're approaching some value up here. Okay. Now you may say, well, how is this new limit definition different than the old limit definition? And the difference between them is that our function can contain a left or a right-handed limit, a one-sided limit, but not contain an overall limit. So let me give you an example. So let's say our function looks something like this. And let's say this is at a value of 2. This is at a value of 1. And this is at a value of 3. Then what we say is the limit as x, because this is our x-axis, as x approaches 2 from the left side. So let me write that down for you. This is the limit as x approaches 2 from the left of our function f of x. So we'll say this is f of x. Well, as we come in from the left side, our height values are approaching the value 1. Right? If you look here, here's the height value, here's a height, here's a height, here's a height. They're getting closer and closer to 1. So we say that this is equal to 1. That's it. That's the left-handed limit. It's a one-sided limit. We might ask, what is the limit as x approaches 2 from the right side of the function f of x? Well, as we come into 2 from the right, our height values are getting closer and closer to 3. So this is a one-sided limit, this is a one-sided limit. They don't have to be equal to each other for them to exist. Now for the overall limit, and this is what's important, for the overall limit as x approaches 2 to exist, these guys have to be the same. So the limit as x approaches 2 of f of x does not exist because these two guys, this number right here and this number right here, are not the same. But if they are, then you have your overall limit existing. Now we can talk about continuity from the left or the right side as well. And how we do that is we say that continuity exists if the function height value at the x value is the same as the limiting value. So this function right here is not continuous from the left because the function height value is up here. But it is continuous from the right because the limit is equal to the function at the limiting value.